What if I told you that scientists have found a way to bend time itself? Or that we might be closer to living under the ocean than on Mars? Today, we're exploring the most fascinating frontiers of science that are challenging our understanding of what's possible. I'm particularly excited about these stories because they represent that perfect intersection of mind-blowing science and practical applications that could transform our future. Let's dive in. Let's start with something that sounds straight out of science fiction: time crystals. Physicists have successfully created what they're calling time crystals and time quasicrystals inside diamonds. Now, these aren't mystical gems that let you travel back to fix your embarrassing high school moments. They're actually a newly discovered phase of matter that operates on perpetual motion, something previously thought impossible under the laws of thermodynamics. What makes these time crystals revolutionary is that they maintain a pattern that repeats in time rather than just in space, like regular crystals do with their atomic structure. Think about it like a clock that ticks forever without needing a battery. The implications for quantum computing are enormous. Current quantum computers struggle with maintaining quantum states because of environmental interference. Time crystals could potentially solve this problem, offering more stable qubits and opening doors to computational power we've only dreamed of. While billionaires like Elon Musk and Jeff Bezos are racing to colonize Mars, one mysterious billionaire is looking in the opposite direction, toward the depths of our oceans. The DEEP project, headquartered near Chepstow, Wales, has secured over £100 million in funding to establish a permanent human presence underwater by 2027. This isn't just about building a fancy underwater hotel. The project aims to create long-term habitats where people can live and work beneath the waves. What's particularly fascinating is how this revives an old dream from the 1960s, when Jacques Cousteau experimented with underwater habitats. The difference now: we have advanced biotechnology, AI, and marine engineering that make long-term underwater living actually feasible. The challenges are immense, from regulating oxygen levels to maintaining psychological health in the absence of natural sunlight. But the potential benefits are equally significant. A permanent underwater presence could revolutionize marine research, helping us better understand climate change impacts on our oceans, while potentially opening new frontiers for sustainable resource development. Speaking of space and ocean exploration, NASA astronauts Butch Wilmore and Sunita Williams recently returned to Earth after 9 unplanned months in space. Their story is remarkable. What was supposed to be an 8-day mission to test the Boeing Starliner capsule turned into a prolonged stay at the International Space Station when technical issues made the capsule unsafe for return. The successful splashdown off the Florida coast, curiously observed by dolphins, marks the end of a mission that tested not just technology, but human adaptability and resilience. This connects to NASA's Lucy mission, which is preparing for an April 2025 flyby of the asteroid Donald Johanson. New modeling suggests this small main belt asteroid formed about 150 million years ago, when a larger parent asteroid broke apart. The Lucy mission exemplifies our continuing quest to understand the origins of our solar system, planning to visit 11 asteroids over its 12-year mission. These space rocks are essentially fossils of the planet formation process, holding vital clues to our cosmic history. Now let's talk about one of the most fundamental scientific questions. How did life begin on Earth? The classic Miller-Urey hypothesis suggested that lightning strikes in Earth's primordial oceans triggered the formation of the first organic molecules. Critics have long pointed out a major problem. The oceans are too vast and lightning too infrequent for this to be plausible. But researchers at Stanford University have proposed an elegant solution: microlightning. When water separates into droplets, like in waves, waterfalls, or spray, the droplets develop electrical charges based on their size. Small drops tend to carry a negative charge, while larger drops gain a positive charge. When these differently charged droplets come close to each other, they exchange tiny sparks of energy, what the researchers call microlightning. In their experiments, they demonstrated that spraying room-temperature water into a mixture of early Earth gases created all the organic molecules previously observed in the Miller-Urey experiment. Think about it. On early Earth, there would have been water sprays everywhere, creating countless opportunities for these chemical reactions to occur. This could solve one of the biggest mysteries in science: how inanimate chemicals transformed into the building blocks of life. Finally, let's explore how our understanding of physics has been shaped by some unexpected influences: angels and demons. While this might sound like we're veering into pseudoscience, a fascinating article explains how medieval debates about angels actually helped develop key concepts in modern physics. Medieval philosophers and theologians used angels to think through problems of place, dimension, and motion. Since angels were believed to be immaterial yet located in specific places, scholars had to develop sophisticated theories about how something without a body could occupy space and move through it. These debates led to more mathematical, less intuitive concepts of space and dimension that would later influence modern physics. Even after belief in actual angels faded, physicists continued using supernatural intelligences as thought experiments. Maxwell's demon, Laplace's demon, and the Phyllon-Pearson demon all served as useful placeholders, helping physicists find scientific explanations for only vaguely imagined solutions. Einstein himself claimed to have banished the ghosts of absolute time and space with his theory of relativity. It's a fascinating reminder that our most cutting-edge scientific concepts often build upon metaphors and thought experiments that help us grasp the ungraspable. As we've seen today, science continues to push boundaries in unexpected directions, whether it's bending time inside diamonds, building underwater colonies, understanding the origin of life through microlightning, or tracing how medieval angels shaped modern physics. These discoveries remind us that the universe is far stranger and more fascinating than we often imagine. The most exciting thing? We're just scratching the surface. The next breakthrough that changes everything could be happening in a lab right now. If you enjoyed this exploration of cutting-edge science, hit that subscribe button and let me know in the comments which of these discoveries you find most fascinating. Until next time, stay curious.